Hi class, we're looking at using the multiplication properties and division property of inequalities in order to solve inequalities. Let's look at the multiplication properties first. These properties, multiplication and division, there's a trick to them you have to watch out for. It tells us for every real number a and b, and for where c is greater than 0. Okay, so these are positive numbers. Anything that's a positive number. If you have a is greater than b, and you multiply both sides by the same value, you get a true statement, which is a times c is greater than b times c. The same is true if you have a is less than b, and you multiply both sides by c again, a will still be less than AC will still be less than BC. Let's think about that for a second. If we have 4, which is greater than -1, and we multiply both sides by 5, we end up getting 20 over here and -5. So 20 is still greater than -5. If we have -6 is less than 3, and we multiply both sides by 5, we get -30 here, which is much less than the positive 15. Okay? Now, here's the trick. When we're multiplying and we have an inequality in which A is greater than B, and we multiply both sides by C, but notice here we have C is less than 0, so that tells me C is going to be a negative number. What ends up happening is our inequality is flipped. And we're going to see 2 examples of why this happens. The same is true here. We have A is less than B, but when you multiply them by a negative, both sides by the same negative number, you end up getting the A times C is greater than B times C. Let's look at some mathematical examples here. We have 4, which is greater than -1. We multiply both sides by -2. So now we have a -8 over here, okay? And we have a positive 2. Well, which one is greater? Notice how the inequality sign is flipped, because the bigger the negative number, the smaller it actually is. If you have -6, which is less than 3, and you multiply both sides by -2 again, you're going to get a positive 12, because remember, a negative times a negative is a positive. And over here, you're going to get a -6. So which one is going to be greater? Again, it's opposite of the original sign. So you have a greater than sign here. And we have, make sure you note, we have the same, this property is also true for the greater than or equal to or less than or equal to properties. All of these are the same if you add that line underneath any of those inequality signs. The properties still hold true. Let's look at division. Okay, division's following the same kind of idea with the multiplication. We have A is greater than B, and we're going to divide both sides by the same value. As long as C is a positive number, the inequality is going to still hold true. The same with a less than symbol. The inequality is going to hold true. If we have 6 is greater than 4, we divide both sides by 2, we end up getting 3, which is greater, not much greater, but it's greater than 2 over here. If we have 2, which is less than 8, and again, we divide both sides by 2, we still have the left side being less than the right. Now, when C is less than 0, we have a negative number. It's very important. We divide both sides by a negative number, the inequality is going to be flipped again. Okay? The inequality is going to be flipped. Let's look at some mathematical examples here. We have 6 is greater than 4. We divide by a negative number on both sides. We end up getting -3 and -2. Remember, the smaller the negative number, the bigger it is. So our inequality sign is flipped. The same with our less than. We divide both sides by a -2. We get a -1, which is going to be greater than -4. Think about it this way. You owe me $1 or you owe me $4. Who has the smaller amount of money? So that inequality sign is flipped. On to the next page. Let's use these properties and see these properties in action. All right, let's look at example 1. We're multiplying to solve an inequality. We have 3 is less than or equal to -3/5 x. So we want to solve for x.